that background, the same question about given you, but it's saying a story. And the story is that the range is showing a lot of the ability. 36 shows that the numbers are falling far apart from each other. But when you look at the letters, this is 4. It shows that these numbers are not falling far apart from each other, showing that there are some outliers. When you cut off the higher numbers, 3 of them, you were cutting off 80, you were cutting off 88, and you also cut off 65. You put those away. When you are cutting off the lower numbers are close to one another. You remove 52, you remove 53, and you remove one of the 56s. The ones which you remain with in the middle were those which are falling close to one another. The ones that are these outliers. And these outliers causing the range. Actually, we worry about computing the pattern deviation when you have a situation like this where there are some scores falling very far away from the typical performance. The majority of the performance are within here, but these guys are outliers. So that's why we cut off that 25% of the scores. You cut them off from this side, you cut them off from that side, and as you are cutting them off, if it is a negative skewed distribution, the 25% you are cutting off here will be removing the outliers. If it is a positive skewed, you are removing these, which are outliers. And therefore, your pattern deviation shows the typical performance in terms of the ability, but the range does not do that. So that's the story that the numbers show. Has this been helpful?
Yes.
Okay. Your colleagues will see you. So we also maybe some parents to switch audience. Yeah. Are we okay to continue? Okay. Yeah, I got it now. When we talk about the ability, we talk about the range and the pattern deviation and the exercise of that. I guess we are now we could handle on those. The third index we use for measuring variability is variance or standard deviation. these are related. The standard deviation is the square root of the variance. So that's why I put them together like that. So in most of the statistical analysis, you will not find people talking about the quarter deviation. The range, yes, once in a while they talk about the range, but the most frequently used measure of variability is the standard deviation. It is a ratio scale, a ratio statistic, meaning that it is used in data which has a true 0 point as well as the equal intervals between numbers. And it is used in that kind of data because it is based on the mean, and as we saw, the mean is an arithmetic average where you are adding, dividing, and you cannot do those things when you don't have a true 0 point. You cannot do those things when the numbers are not having equal intervals. That's why the standard deviation and the variance are only used in a ratio scale. Of course, you see people also using that in the interval scale, but as we're talking about the mean, in interval scale, you know that they are not using it very accurately. It becomes a good measure in terms of the measuring scale only, but in terms of the attribute itself, you be lying. But people do use it, do use the standard deviation and variance in the interval scales. However, you want to use it in a ratio scale. Now, when we're talking about the standard deviation, it is actually based on what is referred to as a deviation score, whereby when you have computed a mean in any data set, the mean is the central point of that data set. Of course, it is the measure of combined performance, isn't it? Like in our example we said the mean was the what? 51 for the what? 61.4. Okay. What was the lowest score? 52. Now, when we are talking about the deviation score is defined as the score, if the true is, minus the mean. So that would be the deviation score. So for each score in the distribution, you compute the deviation scores. But this one was, what is this kind? To be a minus, should be minus 8 point something, minus 8.6. Good. Yeah? Oh, that was great. So I'm not putting my mathematics. 1.4. Let's take another score. One. The other score we had was 88 minus 61.4.
This is
26.6. If you did this for all the scores and tried to sum them, you will have one challenge. One challenge will be okay. The summation of the deviation score will always come to 0 because they are negatives and positive numbers. So the negative numbers will always cancel with the positive numbers. And you can try with that example I gave you of that data. I compute these deviation scores, they will all come, and you sum them, they will all come to 0. Because the 61 is a central number. So the numbers below it will be negative. The numbers above it will be positive. Positive and negative will cancel. Okay? So because of that problem, when you get these deviation scores, they are always square. 26.6. So the answers you get, and you sum them. Okay? If you sum the square deviations, you always get a positive answer. And that answer you get is what is referred to as variance. Somebody say it back to me in your own language. Just make sure we are saying the same. We are saying that both the variance and the standard deviation, they are based on the mean as a point of reference, and the computation uses what we call deviation scores. So each score has to be related to the central score, which is the mean. So that we do by taking the score minus the mean. And what you come up from that is called a deviation score. So you come up with deviation scores which are negative, and you come up with deviation scores which are positive. Now, if you were to come up with the measure of a standard deviation, ideally we should have just summed them up. But when you sum them up, they always add to 0 because of the positive numbers, and the negative numbers, they always cancel one another. And to avoid that problem, we square the deviation scores so that you end up having a positive summation of those positive scores. Okay? And when you have squared them and you get that positive number, that's what is referred to as variance. Okay? But the problem is, we started with scores which are in this range, but by squaring them, we have taken them to an upper scale. So in order for you to come back to the original scale, you have to square the variance in order to come up with a standard deviation. In terms of definition, that's what is variance is. That's what standard deviation is. And the standard deviation is by far the most widely used measure of variability in any data set. Questions? Should I say it again? The Muslim is not busy. Of course, when you go into there are formulas which are normally used for computing the variance, for computing the standard deviation, simplifying all what was explained here. But I'll share those formulas. But then if you just get the formulas without understanding what is there, then it doesn't work. My interest is for you to understand the concepts. We take the mean as the point of reference. And why are we doing that? We are interested in looking at the variance rate, how far each score is falling from each other. And for us to answer that variation, the best way is to have a point of reference, which is the mean. Because the mean is carrying in it the performance of each score, the value of each score in the distribution is included in the mean. You add 52, 53, 51, up to 88. So it means the values of all those scores went into that summation rate. And then you divide it by the number of scores to get the mean. So the mean is a combined performance. It gives you the idea of central performance of that distribution. So if you want to measure how each score is falling away from each other, then you'll be using that point of reference, which is the mean. And then you want to be seeing the distances of each score falling off from that point of reference. And that's what we are doing in this set. Subtracting 61 from 52. We are trying to measure how far away 52 is falling from the point of reference. Okay? Is that making sense? We took 88 minus 64. What we are doing is to measure the distance away that 88 is falling from the point of reference. And that is what is referred to as a deviation score. Ideally, if these scores were not supposed to be, there was no variability, then each of those scores, all those 15 scores, should have been 61.4, 61.4, 61.4, 61.4 throughout. But we had 52 because it is varying away from the point of reference. Zikukubona something? Yeah? Zikuvela? Or zikuvele? So that deviation score is showing you how the data is deviating from each other. But the problem is when you sum up those deviation scores, because some will be negative and some will be positive, they will cancel each other and they will always add to 0. You can take any set of numbers, you can just string any numbers, compute the mean, and then compute the deviation scores, add them. You will find that they will always add to 0 because they are positive and negative cancel each other. And to avoid that problem of summing to 0, we square them. So that when you add the square deviation scores, you always get a positive number. Why? Because negative times negative equals positive. Positive times positive equals positive. So you always get a positive number. But at a higher scale than the original numbers because you square them. Okay? So that one, that the square, the higher scale, is what is referred to as variance. Yeah? Okay. Okay. Her question is what she has done. She has computed this minus 9.4 times minus 9.4 and has got an answer. 26.6 times 26.6. She has got an answer. And the question she's asking is, are those the variances? No. Those are squared deviation scores. 9 minus 9.4 is a deviation score of 52 from 61. In other words, I'm saying that the 52 has deviated from 61. 61 shows the central performance of your whole distribution. By coming up with a mean, the mean is telling you that the central performance of this distribution, the combined performance of this distribution is 61. Okay? But the fact that you have 52, you have 53, you have 56, these guys are falling away from where the central performance is. So they are deviating. The fact that you have 65, you are deviating from the mean. Okay? So those are deviation scores. The differences between the mean and the score are called the deviation scores. And when you square them like this, they are called the squared deviation scores. So what we have computed there are squared deviation scores. Now, for you to come up with a variance, if we computed all the 15 squared deviation scores and we added it there, you will have variance. So variance is the summation of the squared deviation scores. Have I lost you, Faith? Okay. Let's write this in terms of common number. Yes. Score. Oh, example. Give us an example. So if you take the score minus the mean, it is referred as deviation score. Okay? 61 minus 52 is deviation score. That 52 minus 61, not 61 minus, but 52 minus 61 deviation score. 88 minus 61 is a deviation score. But the summation of deviation scores equals always 0. Because the deviation score will be some will be positive, some will be negative. So to avoid this problem, you sum the deviation scores square. Okay? And when you do that, you couple the areas. You know, as much as so this is deviation square. Deviation square. Now, since you square them here to come with the variance, you need to bring that back to the level of your scores. To come up with standard. And we can come back to the integration. We use the same data to compute those things. With those definitions, is it really essential?
Yes. It's a shade example.
Okay. So this variance I'm showing there, you can actually simplify it by this formula. In fact, this formula I'm showing here, okay, I forgot to do one thing there on the variance. You have to divide it by the number of scores. Anyway, that will become that. But otherwise, if you use that formula, then you are giving us an idea of how the scores are falling apart from each other, but at a higher level because of the square you have done here. If you square root this, then you'll be measuring how the scores are falling apart from each other. And that is referred to the variability of the scores. When you miss, we will, in fact, you can even try yourself with the data which we have done, and we
There. On the floor. It's that one.
this one.
I'm not sure.
You.
Oh,
Oh, this should be required by number of square feet. And let's see if the you can try to practice it, we'll do it together here as a group and see what it makes sense. Otherwise, nice work.
Oh ya? Urufuna ulu baboneke. Sasa kutoka kutawa nazo. That time naiwacha na kana